Welcome back on the channel, and today we are going to learn about the redox reactions. While we are learning this, we are going to cover the syllabus of IGCSE and GCE plus Edexcel. So we are going to start. So actually we are going to learn about the redox reactions. In the syllabuses we are going to cover our IGCSE, GCE O level and IGCSE Edexcel. So what is the redox reaction? So the redox reaction is actually a combination of two words, red and ox. Red stand for reduction, whereas the ox stand for oxidation. So when we combine these two, we get a meaningful sentence that we can say a reaction in which both oxidation and reduction reactions takes place side by side. So we are going to discuss what is oxidation and what is reduction. Keep that in mind. Oxidation is exactly the inverse of reduction, or reduction is exactly the inverse of oxidation. So if we successfully learn what is oxidation, we can remember what is reduction. So oxidation is the loss of electrons, whereas reduction is the gain of electron, exactly the reverse or inverse of oxidation. Second, oxidation is the loss of hydrogen. Reduction is the gain of hydrogen. Third, oxidation is the gain of oxygen, and reduction is the loss of oxygen. Fourthly, oxidation is the increase in oxidation state or oxidation number, whereas reduction is the decrease in oxidation state or oxidation number. So to learn what is actually oxidation and reduction, we are going to learn about the reaction between magnesium and oxygen. When magnesium burns in oxygen, magnesium oxide is formed. The chemical equation for the reaction between magnesium and oxygen can be represented like this. In this reaction, you can easily see that magnesium has clearly been oxidized. But how? It is clear that it is involved in gaining oxygen. So oxidation, whereas the oxygen, you can easily see, is reduced because the oxidation state of oxygen is decreased to -2 from 0. So in this context we can say oxidation and reduction always take place together. So the oxygen must have been reduced in this reaction. But how? But the question, how we can say that? So let's see what is happening to the electrons. In this situation you can easily see magnesium, being metal, has 2 extra electrons in its last shell and is unstable. To make itself stable, it tries to lose those electrons. On the other hand, oxygen has the deficiency of 2 electrons in its valence shell, and being a non-metal, it tries to gain those 2 electrons to complete its octet. So this results in a formation of a compound called as magnesium oxide. So it is very clear magnesium is losing electron, whereas oxygen is gaining electron. And as we learned in the previous, that Loss of electron is oxidation, whereas the gain of electron is reduction. Magnesium losing electron converting into magnesium ion, whereas oxygen gaining electron and converting into oxide ion. So the more important to properly understand what is oxidation or reduction or redox reactions, we have to understand what is oxidation state or oxidation number. So oxidation state or oxidation number is the charge on any species, or we can also say that oxidation state or oxidation number is the number of electrons involved by any atom in a specific compound. To work out the oxidation state or oxidation number of an atom in a compound or a molecule or in a radical or a complex ion, we use the following rules. According to the first rule, we can easily say all elements have zero oxidation state. Keep that in mind. We have different type of the elements. For example, helium, neon, argon, H2, N2, these are all elements. And as you can clearly see, helium, neon and argon are from group 8 and exist as a single atom. So these are monoatomic elements, whereas hydrogen, nitrogen, oxygen and all the halogens exist in diatomic form, so they are diatomic elements. Ozone is triatomic, sulfur octa, whereas phosphorus is tetraatomic element, and all the elements have zero oxidation state. Second rule, the oxidation number of any simple one atom ion is equal to its charge, or shortly we can say any simple ion has the oxidation number equal to the charge of that simple ion. For example, sodium ion has oxidation number of +1, whereas the chloride ion has oxidation number of -1 and calcium ion has oxidation number of +2. So if we have simple ion, the charge on that simple ion will be equal to the oxidation state or oxidation number of that ion. Third rule says the oxidation number of hydrogen in covalent compounds is +1 and in ionic hydride it is -1, whereas the oxidation state or number of oxygen is always -2 in all of its compounds except hydrogen peroxide, which has the formula H2O2, and in hydrogen peroxide the oxidation state of oxygen is -1. The next rule says the algebraic sum of oxidation number of all atoms in the formula for all neutral compounds must be 0. So when you remember all these rules, remember that when you keep all the rules in your mind, you can easily calculate the oxidation state. And if you successfully calculate the oxidation number, you can easily understand what is happening. Either the oxidation state is increasing or decreasing, and in this way you can easily figure out that the substance during any chemical reaction has been oxidized or reduced. Now we are going to apply all these rules to properly work out how these rules work. So we are going to calculate the oxidation state using all those rules which we learned. So simply I'm going to ask you simple situations that find the oxidation state of the sulfur in the followings. The first we have S8. As we discussed in the rules, that if we have an element, and what is the situation, we can figure out if something is an element or not. If something is bonded with its own atoms, then this will be called as an element. Like in this example, sulfur is bonded to other 8 atoms, making S8 molecule. So as it is an element, so its oxidation state will be 0. So remember the oxidation state and the logic, how we calculated, how we concluded that the oxidation state of sulfur is 0, or that is why sulfur could be written as S or S8. Next example is about sulfur dioxide, and we are going to find out the oxidation state of sulfur in this compound. From the fourth rule, we learn that the algebraic sum of all the atoms in a neutral compound is always equal to 0. So keeping that statement and that rule in our mind, we can easily calculate the oxidation state, saying that in this compound we have 3 atoms, 1 is sulfur and 2 are oxygen. We are going to find the oxidation states of sulfur, so we are going to put sulfur as S and plus 2 times the oxidation state of oxygen. And from the previous rules which we learned, the oxidation state of oxygen is always minus 2 unless it is in the form of hydrogen peroxide. So when we put all these values, we can easily calculate that the oxidation state of sulfur is plus 4. Another example, now we have more atoms. We have total 7 atoms in this molecule. 2 are of hydrogen, 1 is sulfur, and 4 are of oxygen. Again, as we learned in a neutral compound, the sum of the oxidation states of all the atoms must be 0. So keeping that situation in our mind, we are going to make an algebraic expression that will shows that we have 2 hydrogen atoms, and we are going to put the value of oxygen or the oxidation state of hydrogen that we know from the rules, which is plus 1. Whereas sulfur we are going to find, so we put the sulfur as S, or even we can put as an X, unknown. While we have 4 oxygen atom, so the oxidation state of oxygen is always minus 2 unless it is hydrogen peroxide, and the sum of all is 0. So calculating, first of all putting the values and then calculating, so the final answer we calculated shows that the oxidation state of sulfur is plus 6. Okay, you may not see that value, but remember that when you solve this situation, the oxidation state of the sulfur will be plus 6. Another example shows that we have K2S2O3, another compound called as potassium thiosulfate. If we are going to find the oxidation state of sulfur in this compound, again use the rule that says that sum of all the oxidation states of all the atoms will be equal to 0 in a neutral compound. So keeping that situation in mind and replacing all the suitable values, we can find the oxidation state of sulfur in this situation. And finally, the answer shows the oxidation state of sulfur is, you can see, plus 2. So you can easily calculate the oxidation state of any unknown atom in any compound using all the oxidation state rules. Another example to confirm that we are able to find the oxidation state of a complex ion or atoms in a complex ion. We discussed that the sum of the oxidation states in a neutral compound is always 0, but if we have a radical or a complex ion, then the sum of oxidation states of all the atoms will be equal to the charge on the complex ion. So keep this situation in mind. We can say that in this situation we have 1 sulfur, 4 oxygen atom, and the overall charge on that complex ion is -2. So we have to make an algebraic or a mathematical expression that will show the situation like you can see on the screen, and if we calculate this we can see what is the value of sulfur, and it is +6 again. So keeping these oxidation state rules, you can easily figure out what is the oxidation state, and that will help a lot to find out which substance oxidation state is increased and which one's oxidation state is decreased. And you can figure it out. Whatever the question examiner asks you, you can easily find and summarize why something is oxidized and why something is reduced, or the reaction is a redox reaction or not. So now we are going to learn about the oxidizing and reducing agents. For this, we are going to understand that when hydrogen reacts with heated copper oxide, the following reaction takes place. In this reaction, you can easily see that the copper oxide is reacting with hydrogen gas and producing copper and water. So we can say the copper 2 oxide is reduced. Why? The reason behind that, the copper oxidation state is decreasing from +2 to 0. On the other hand, you can see the hydrogen is helping copper to do so. Why hydrogen is helping copper oxide to convert into copper? That means the hydrogen is helping copper oxide to get reduced. That is why we can say hydrogen is a reducing agent. The hydrogen is itself oxidized. You can easily see the oxidation state of the hydrogen is increases from 0 to +1. Or even we can say that hydrogen is involved in gaining oxygen, and the gain of oxygen is oxidation. But actually the copper oxide is helping hydrogen to gain that oxygen. It means copper oxide is helping hydrogen to get oxidized and is called as oxidizing agent. So keeping this information, this example in your mind, we can easily define what is an oxidizing agent. That a substance that help others to oxidize but in response reduced or reduced by itself. That is called as oxidizing agent or oxidant. On the other hand, a reducing agent reduces another substance and in response itself oxidized. So that will be called as a reducing agent or reductant. Now we are going to discuss some good oxidizing agents and reducing agents. You must remember all these, the formulas, the names, and the color change, so that you can easily quote what should happen when something reacts with the other one, and it will confirm the presence of an oxidizing or reducing agents. Oxidants and reductants. What are the good oxidant or good oxidizing agents? Number 1, acidified aqueous potassium dichromate 6. The formula of the compound is K2Cr2O7. Its original color is green, and when it get oxidized, or when it is helping something to get oxidized and on by itself reduced, its color will be changes from orange to green, and it will confirm that it is used as an oxidizing agent. So there is a reaction you can easily see. we are adding potassium dichromate, having potassium dichromate, and we are bubbling sulfur dioxide gas from it. And you can easily see the color is changing from orange to green. Okay, so initial color, starting color was orange, but as we pass the sulfur dioxide, as we bubble the sulfur dioxide gas, the color start to change and finishes at green. Due to the blue background, you may see some, or you may have some difficulty to recognize the colors, but actually when you perform this experiment in the lab, you can easily see the change in colors. Another good oxidizing agent is acidified aqueous potassium manganate 7. Formula of the compound is KMnO4, and its original color is purple. When it helps anything to oxidize and it reduces by itself, its color changes from purple to colorless. To better understand, you can see this. We have a solution which has a proper purple color, and when we are adding into another color, another liquid, another chemical, its color is immediately disappears. We can use the term decolorizes, or even we can say its color changing into colorless. So color changes from purple to colorless confirms that a reducing agent was there, and potassium manganate acting as an oxidizing agent. Another good oxidizing agent is hydrogen peroxide, but remember there is no proper observation. So if we are confirmed and we are sure that we are going to oxidize another substance, then we can use hydrogen peroxide, and it positively oxidizes the other substance. Now moving towards the reducing agents. So the good reducing agent is aqueous acidified potassium iodide. Formula is Ki, and its observation when it acts as a reducing agent is its change in color, and it is from colorless to brown. You can see here, when we are adding aqueous potassium iodide to a colorless solution, the color changes and it will turn into a brown color. Confirms that the colorless solution which we have already is reduced. That is why we can say potassium iodide is a reducing agent. So some other good reducing agents includes carbon monoxide and hydrogen, as well as sulfur dioxide and ethanol. So these are some good reducing and oxidizing agents. You have to remember most prominently these three which have a proper and prominent color changes. So one more thing which we have to discuss is no redox reactions that are more frequently asked in IGCSE and in GCE syllabus. Examiner asks you what are the reactions, or which option the reaction is a no redox reaction. So in simple, if there is no oxidation or no reduction, then we can say that the reaction is a no redox reaction. For example, the neutralization and precipitation reactions are no redox reactions. Okay, so keep that in mind, that always the neutralization and the precipitation reactions are no redox. The reason behind that, there is no change in oxidation number of any of the reactants. They remain intact. Whatever their oxidation state is previously in the reactant side, that oxidation state will stay the same in the product side. So we can say that all the neutralization and precipitation reactions are no redox reactions. So you can see here in this example, HCl is reacting with NaOH. HCl is an acid, whereas NaOH is a base or alkali. When they react, they produce sodium chloride and water. If you closely observe the oxidation states of all the reactants and products, they are the same. Mean there is no change in the oxidation states. That's why we can say this is no redox reaction. Another example is precipitation, and you can see A precipitation reaction is the reaction in which soluble salts are mixed together to produce an insoluble salt. This type of reaction is called as a precipitation reaction. The best example is the reaction of aqueous sodium chloride with aqueous silver nitrate. When these two react together, we get silver chloride, which is insoluble salt and produces a precipitate, a white color precipitate. Now, if we closely observe their oxidation states, so we can easily confirm that there is no change in the oxidation states. Okay, so in short, these are the reactions which we can easily say there is no oxidation or reduction, so they are no redox reactions. So I discussed shortly about the redox reactions, and hopefully you all understand. In my future video, in next video, I will try to solve some of the questions from IGCSE and GCE so that you can easily understand what type of the questions are coming in your exams and what or how you are going to solve those questions. Okay, so please keep practicing, keep solving some of the oxidation states, and try to memorize all the oxidation state rules. That will help a lot. So I will upload inshallah few of the question containing worksheets or solving questions from the past papers. We can easily understand what is oxidation and reduction reactions. Keep in touch and subscribe the channel if you yet not subscribed, so that you can easily get the future videos.